Hello, Midnight Coders. Every programming language carries scars, and Java is no different. So, for decades, Java had a lot of people complaining that it's slow, startup times take forever, and memory usage can get pretty large. The engineers behind the language itself ask their own questions, and the next generation of JVM is on the horizon. So, before we dive into talking about JEPs, what the hell is a JEP? So, a JEP or JEP stands for JDK Enhancement Proposal. And every new feature in Java starts its life as a JEP. You can think of them as blueprints for the future of the language, documenting what the future does, why it matters, and how it should be implemented before it ever ships in a JDK. Now, when I say modern Java, I'm not talking about a version number. No, I'm talking about the mindset. So it's Java that embraces concise, expressive code built on powerful JVM innovations such as the virtual threads, foreign function and memory, um, the eventually the value classes. So modern Java lets developers spend less time writing boilerplate and more time solving real problems, while the compiler and the JVM do more of the heavy lifting. Nobody gets excited about garbage collection until the application starts to freeze. So, this chip increases application throughput when using the G1 garbage collector by reducing the amount of synchronization between application threads and garbage collection threads. So, what the hell does that mean? Well, because every Java application uses garbage collector, whether it's Spring Boot, Minecraft servers, Discord bots, enterprise software, everything. And if the JVM gets faster, your application gets faster without you ever touching a line of code. So, takeaway here is that sometimes the biggest performance improvements is literally just is deleting 0 lines of code. Now, why should you care? Well, this JEP specifically reduces synchronization between application threads and the garbage collection threads, improving throughput rather than pause times. Every time your application starts, it rebuilds the same objects over and over and over, every single launch. So this JEP enhances the ahead of time cache, which enables the hotspot JVM to improve startup and warm up time so that it can be used with any garbage collector, including the low latency Z garbage collector. Um, and this is achieved uh, by making it possible to load cached Java objects sequentially into memory from a natural garbage collection um, agnostic format, rather than map them directly into memory in a garbage collection specified format. So, what the hell does that mean? The JVM can reduce cached object graphs for a previously run application, and then instead of rebuilding them every time. So you can think of it like meal prep. You can cook the meal once and then eat for a week. So why should you care? Well, if you happen to have something that takes a bit to initially load, but then it gets rebooted or maybe scaled up horizontally for busy hours, that boot up time and effort to recreate the same exact objects has a cost, whether it is microservices, cloud deployments, containers, CLI tools, anything that starts frequently. Um, so, takeaway here is that if you've ever restarted Spring Boot 50 times in an afternoon, this feature was built for you. Every language carries a ghost, and Java just so happens to have a lot of them. So this time around, we finally removed, or they finally removed, the Applet API, which was deprecated for removal since JDK 17 in 2021. And it is obsolete because neither recent JDK releases nor current web browsers even support applets. Now, what does that mean? Well, Java is finally removing applets because browsers stopped supporting them a few years ago. And other ancient technologies like applets, Cobra, Security Manager, old browser plugins, some of these things just have to go. And deleting old code is just as important as writing new code because every obsolete API costs us maintenance, documentation, testing, security reviews, and removing dead weight just makes the JVM or Java in general healthier. So, takeaway here is that good software isn't just about adding features. Sometimes it's about having the discipline to let old ones die. Java's switch statement has been slowly evolving from a glorified if statement into an actual language feature. So this JEP happens to enhance pattern matching by allowing primitive types in all pattern contexts, whether you're using instance of or switch. So this will just work. Now, what exactly does this mean? Instead of instead of writing giant nested if-else statements for primitives, you can now use pattern matching consecutively across primitive types. So, for example, if you had a string that was supposed to get the response code status, it might look a little bit like this. And then it may look a little bit like this now. See the difference? So, why should you care? Well, Java is reducing boilerplate, which means less repetitive code, cleaner intent, fewer bugs, and it this isn't about saving 5 keystrokes, okay? It's about making Java feel like one language instead of three that are stitched together. Have you ever started an application and wondered why it takes forever before your code even runs? Lazy constants are objects that hold unmodifiable data. They are treated as true constants by the JVM, enabling the same performance optimizations that are enabled by declaring a field final, except compared to final fields, lazy constants offer greater flexibility as to the timing in which they are initialized. So, what does that mean? Well, when a Java class is initialized, Java normally eagerly initializes static fields. So those expensive configuration objects, the huge lookup table, the massive regex, even if you're never using it, lazy constants say, let's just wait until somebody actually needs this. So computers are fast, wasting work is still pretty slow. Java objects are expensive. They're they've always been expensive, and most of us just accepted that this cost out of the box. It's just OOP. Value objects are immutable and lack object identity. Value objects are distinguished solely by the values of their fields and can be represented by the JVM in ways that improve performance. What the hell does that mean? So value classes let Java create an object without an object identity. You might so you might want to use some sort of simple values for describing a coffee, like for example, how many milk and sugar are in it. Now, you don't actually create a full-blown Java class object. You only care about the actual data itself. Value classes let the JVM treat the object almost as if it were just the two integer types instead of a full heap object. And for years, people said Java could never be as memory efficient as C# or even Rust for data-heavy applications. Meanwhile, Valhalla is over here saying, yo, hold my coffee, bro. I got this. So I hope you see the horizon of Java like I do, and the bright future that is to come. And if you would like a deeper dive on or a real talk explanation about some of these different projects that the OpenJDK engineers are working on, Leiden, Amber, Valhalla, you name it. If you want a deeper dive, let me know in the comments below what you want to hear, and I'll make it happen. And if you made it this far, drop a penguin in the comments. And as always, everybody, keep your curiosity open, your skills sharp, and that coffee cup full. I'll catch you in the next one.